Okay, in this example, this is example number 2 for chapter 9. We're going to consider a researcher who's studying the mean body temperature of healthy adults and whether or not it's 98.6 degrees. And what this researcher wants to do is she took 230 temperatures of patients and got the following data. And so here's 230 data points. Clearly, I do not expect you to enter any of this in R. I'm just going to literally copy and paste these values in R. So copy and paste, and there we go. Let's make sure we got it all. We have 230 data points. And what we want to do with this is we want to determine whether or not this is enough data to overthrow the convention that the mean body temperature of a healthy adult is 98.6 degrees. Okay, so here's our data. And again, yeah, we want to know, do we have enough evidence to overthrow that idea? So this would be a two-tailed hypothesis test. And this would have our null hypothesis would be, let me actually write this down. I was just going to say it, but I think it might be better if I actually write it. Um, so this is going to be a two-tailed hypothesis test. Our null hypothesis would be that mu is 98.6. Our alternative hypothesis would be that mu is not equal to 98.6. And then we want to run this at the 5% significance level, and then I added on a question, also find a 90% confidence interval. So we'll do both of these using R. Okay, so we'll come back and we'll write this in just a second, but let's go back and let's do this using R. So here's our data set. And again, I don't think X is a great choice for this. Maybe I should call this like temps or something. Like I think it's actually helpful to define your variables using words that kind of indicate what that data represents. So that way, when you look up the temps, that's what it is. But whatever you want to do is fine. So I'm going to run the t.test function, t.test. We're looking at the data temps. Our mu is 98.6, so that's our population mean. And we don't need anything else because we're doing a two-tailed, that's by default. And our confidence level is 95%, also by default. So we don't need to do anything different there. So we're going to run this. We got a really tiny p-value, so it's 0.0001 is our p-value. And what that tells you is that we can be very confident that 98.6 is not the true population mean given this data set. Okay, so given this data set, we can be very certain that 98.6 is not the population mean. Okay, so if this is the test, then we would reject the null hypothesis. And that's really all there is to say here. We would reject the null hypothesis. The only other follow-up is I also wanted you to find a 90% confidence interval. So what we would do is we would change our confidence level to 0.9. And then here we go. So a 90% confidence interval would be here. Notice that everything else is the same, by the way. The p-value is the same. Let's get these both on the same screen, but the p-value is the same. The studentized value, -3.93, is the same. Obviously, we still have the same number of degrees of freedom. The mean of X is the same because it's the same data set. The only thing that's changed is the confidence interval. So if you want a 90% confidence interval, you can just do it this way. So you just add the code, conf level equals 90. Okay, and that's how that would work.